Okay, let's unpack this. You're looking at what basically just appears to be a standard computer cable, right? But it has this crazy price tag of $665.
Yeah, which is honestly quite a shock if you're just picturing a typical copper wire.
Right. I mean, I'm holding the spec sheet right here for the DVIGear DVI-2360-AOC-M. It's an active optical cable. It spans 60 meters, which is almost 197 feet. And our mission today in this deep dive is to figure out exactly what kind of hidden engineering justifies that cost to send, high-quality video across massive distances.
It sounds steep at first. But running data over a 60-meter gap is, well, it's an engineering nightmare.
Oh, for sure.
You're not just paying for wire here. You're paying for a highly specialized data pipeline designed to cross a massive physical space without dropping a single pixel.
Because physical distance is kind of the enemy of raw electricity.
Oh, absolutely.
Like, if you try to shove 4.95 gigabits of data per second through 197 feet of pure copper, you hit massive electrical resistance. It's like trying to whisper a secret clearly across a crowded football field. The signal inevitably degrades.
That's a great analogy. The signal just degrades into unusable noise.
Yeah, it's like sliding a heavy box across sandpaper. Eventually, the physical friction just eats all the energy.
Right. And what's fascinating here is how the cable bypasses that electrical friction entirely. I mean, it uses a hybrid technology.
Hybrid meaning light and electricity.
Yep. The heavy video data is translated into light and sent through 4 polyfluorinated optical fibers.
Polyfluorinated?
Yeah, POF for short. And that part is key. Unlike traditional fragile glass fibers, this is a specialized plastic. It makes the cable incredibly durable and flexible for commercial installers.
Okay, so how does the light actually get generated?
It uses 850 nanometer multi-mode VCSLs, which are...
Wait, VCSLs?
Yeah, basically they're tiny lightning-fast lasers used to shoot that data friction-free across the gap.
I love the idea of swapping electrical resistance for frictionless light. But looking at the specs, it's not purely optical.
Yeah, no, it's not.
It also has 6 traditional copper members running alongside those fibers. So if the lasers are doing the heavy lifting to bypass the resistance, why keep the copper at all?
Because fiber is actually overkill for certain tasks. You still need copper for the low-speed data.
Like what?
Like the ED handshake.
Yeah.
That's the background conversation, where the monitor tells the computer what resolutions it supports.
Oh, right. Up to 1920 by 1200 in this case?
Exactly. But more importantly, those copper wires carry the tiny bit of power required to run the lasers themselves.
Here's where it gets really interesting, though. Usually, when you have an active optical cable doing that complex electrical-to-light translation, it requires a bulky external power adapter.
Oh yeah, usually plugged right into a wall outlet.
Which seems like a massive headache if you're trying to snake this lightweight cable through tight spaces.
It is a massive headache, which is exactly why you won't find a wall plug on this one.
Wait, really? No plug at all?
None. This entire optical conversion process is so efficient that it operates on less than 0.3 watts.
Wow, that's tiny.
Yeah, it just pulls that power directly from the DVI source device. And if we connect this to the bigger picture, this solves a huge logistical problem.
Because installers can just plug it in and it powers itself.
Precisely. Plus, because the heavy data is traveling as light inside shielded metal enclosures, it's highly immune to EMI and RFI.
Oh, electromagnetic interference.
Right.
So you could run this directly over humming power lines or like heavy machinery in a factory.
Exactly. And those intense magnetic fields can't touch the light inside. The electrical noise in a stadium or a hospital won't distort the video feed at all. The signal stays perfectly clean regardless of the environment.
So what does this all mean? Well, for you listening, it means the next time you see a flawless video feed on a massive screen, maybe a mile away from a control room, you're looking at the result of this exact type of invisible infrastructure.
It's the hidden backbone of our digital spaces, really.
Yeah. And the spec sheet even notes this cable is plenum rated, which means its jacket is made of special fire-retardant plastics.
Right, which legally allows installers to safely tuck it away inside a building's air ducts and drop ceilings.
Doing the heavy lifting where no one can even see it. And I mean, looking at the environmental specs, they engineered this thing to operate flawlessly in some extreme temperatures.
Oh yeah, the range is wild. From -4 degrees all the way up to 158 degrees Fahrenheit.
That's serious heat tolerance for a commercial data cable.
It really is.
It raises an important question for you to ponder. If this one highly specialized cable is engineered to survive blistering heat and, massive electrical noise just to keep a video feed alive across a giant room,
Yeah.
what other extreme hidden environments in our physical world are secretly relying on rugged optical fibers right now just to keep our daily digital experiences running smoothly?